Okay, so my name is Santos, and today I'd like to present the project called Software Toolchain to enhance the management and integration of a sustainable campus module. I think that this paper is a little bit different because it's not a research paper. It's more like a project report, so it's more for dissemination. I would like to explain the objectives of the project and also describe some of the results that we achieved over several years. So we didn't finish yet, but we are more or less halfway. Okay, so my presentation is divided in 4 sessions here. So purpose, so I'd like to explain the objectives and describe the project. And later I will show the partial results because we are not finished the project yet and the expected benefits from the project. So first, the purpose. Okay, so the idea here, of course, is to have a complete software toolchain to control this sustainable campus model system. And there are 2 parts for this objective. So the first one is this online energy performance monitoring. So here we would like to develop this tool to show several characteristics, some like a weather forecast, occupancy, user behavior, physical envelope, and energy system operation. So a full monitoring system that works in real time and can show these aspects for the operation of the campus. And also, we would like to have a smart management system that also works in real time and can have multi-objective functions here, like reduce energy consumption, efficiency, and also apply performance standards for the buildings inside the campus. Of course, we are trying to develop this framework. So the idea is to have the system implemented in public buildings, and we have these pilot cases, a pilot case that is a campus. And the idea here is because, of course, it's a research environment. So we can try new ideas, we can try new algorithms and test very innovative functions. So it's a very flexible pilot. And of course, after the objectives are achieved, so we can try to expand that for commercial buildings or private buildings, quite some interesting applications. So for the project description, for the campus, we have 8 applications here, or sub-projects. They are dividing in these 8 modules. Of course, we are investing a lot on local generation, so distributed generation. So most of the investment so far is done for photovoltaic generation, but we also have electric mobility. So inside the campus, we have some electric buses, and the idea is that they can we can use, instead of using diesel, so change that for chargeable electric buses and try to reduce the emissions of the transportation inside the campus. We're also working a lot with retrofit. So a lot of the buildings are quite old and they are not optimally designed to operate in an automatic way or in a with a digital solution in a management system. So a lot of retrofit needs to be done to that, changing a lot of the systems, installing sensors and actuators, and of course having a DMS, a building management system, to handle that in an automatic way. For that, a lot of IoT infrastructure is being installed so far. I would like to present that today to you, some of the initiatives that are being done. But also, we are working a lot with this energy efficiency in buildings and trying to label the buildings with the important characteristics of their consumption, and also their envelope, all the characteristics to have a classification and how efficient the buildings are. And for the last 3 ones, we have electric procurement. So how we we forecast our consumption and how we buy that for the next seasons or even years. This project generates a lot of know-how, a lot of new knowledge that we would like also to expand to the students of this campus. And of course, we have our Power System Operation Center, so a centralized solution that can have full monitoring of the whole campus. And we would like to deliver this solution and make the university work that, run that 24/7. And try to obtain the most advantage as possible from this solution. Okay, so in this project, there are 42 researchers working so far, and we have a 5 million USD of investment and quite a lot of work to be done. So I talk a lot about this framework and the sub projects, but the pilot case is being done in Brazil. So it's in the São Paulo state. So here in the southeast part of Brazil. And this is being implemented in a university. So it's the University of Campinas, UNICAMP. And there are some reasons why this is chosen and why this investment is done here. So 8% of the academic research is done here only in this university. So it's quite a profitable knowledge university here. And we have quite a high percentage of postgraduates. So after the bachelor, quite some investment in researchers in this university. And with more than 2,100 theses and dissertations advances here per year. And the development of the project is being done in the School of Electrical and Computer Engineer. So, and where 30% of all PhD degrees in this field is from Brazil. And has the largest electrical engineer graduate program with a very high rank on most of the index, the Brazilian index, and also from international ones. So I have some photos that I would like to show later for you. So here is the general communication structure. So you can see that we have two centralized elements. The first one is a database. So everything that in the campus needs to be archived, stored in the centralized database, and a lot of information are being getting from all the sensors, all the actuators, and this information needs to be sent to a cloud application. I think that is quite common to have this infrastructure in IoT systems, but it's interesting to see how this large-scale implementations can be done in a campus size of the size of UNICAMP. I would like to discuss a little bit of each part of these modules here and show what kind of protocols we are using to implement them. First of all, we need, of course, if we like to monitor all the buildings, all the facilities, we need to have a very good infrastructure of communication. You can see here a map of the campus, and the green circles shows the Wi-Fi range. So what are the Wi-Fi routers and what are the reach of these Wi-Fi routers? So it's possible to see that they are not enough to cover the whole campus. So we need other technologies, and for that we are using LoRa. So this long distance communication, they have sometimes some problems with broadband, but they can have quite an extensive range of communication. So basically with these two technologies, we can cover the whole campus and don't have any blind spots. So when we have devices, we make sure that in the long run, we can receive these values. Regarding distributed generation, we have a pilot cases in some of the buildings and with solar panels installed on the rooftops. So far we have around 535 kilowatt peak of installation, but there is much more potential. So if we see the campus and all the rooftops and the ones that allows the installation of this kind of systems, we can expand for more than 16 megawatt peak. And so this is quite an interesting case, but this will not be done in the scope of this project. So it's something for the future. Of course, Brazil is known for very warm weather. So most of our energy, the electric consumption is used for cooling. So when we are retrofitting the buildings, we need to think about what are the most expensive items. And here we have two main programs. So the first one is to replace all the old air conditioning for more efficient ones, and have quite a drastic reduction in power consumption, but also changing other loads like lighting to make the system more efficient. So we know that we are consuming the less possible energy in our system. So for our system, we are also modeling and having a digital twin of some of the buildings of the system, and we can measure how the forecast of consumption is according to the real consumption. So having a module and comparing that with the real system. One of the things that we are not very good in Brazil is to have this labeling of buildings and to classify them on a level of consumption. And although we have of course, some regulations and some criteria to do that, most of the buildings don't have this labeling. And we are trying to do that for all the buildings in the campus and have an idea of how good they are in this efficiency. So some of the partial results that we have so far, of course, we have more than 300 IoT devices installed. So they is a big investment to monitor a lot of these measurements. And consumption is one of them. So we need to make sure that all the buildings have at least one point of common connection, and then we can measure these systems. And of course, we need to find a way to visualize this data. And for that, we need to design a mini operation center. So it's a centralized SCADA system that can in real time show what is the consumptions, the issues in the system, and also retrieve rhetorical information. So what happened in the last day, last month, or even what we are expecting to do in the next hour. So we need to have this kind of information. And of course, in order to do that, to have this mini center with several institutions. So we need to have quite a good organization and integration of this data. The way that we are doing that is to have a centralized control hub or a gateway that can take all the measurements from all the sensor devices and send that to our centralized mini center. So usually the gateways, they are connected to the Wi-Fi system. So they need to be on the cover of the spots that I showed you previously. And we have several sensors like temperature, humidity, gas, like CO2, luminance, current, weather conditions, like with these weather stations. And we need to take all this information and send that to our cloud solution. And this is a centralized solution. And here we can gather most of the information and plan that for the next period of our analysis. We have quite some user interfaces to help us to make some decisions, and more algorithms are being designed to make the system more automated. Okay. The last thing that I'd like to show to you is the energy procurement. So basically is compare what we have now with what we forecast and what we bought it for our next period of consumption. Most of them here, unfortunately, are in Portuguese, but it's because this comes from our real dashboards. But it shows, for example, what is our current consumption and what we hired for the next period. So for the next years, we can see that it's designed increase of consumption, and we need to make sure that we are inside the budget here for the project. Okay. So for my last slide is for a discussion of the expected benefits. So I think there are three modules here. Education. So this project is generating a lot of know-how, a lot of learning, and we would like the students to in the UNICAMP University to benefit from that. And several courses are being designed with the experiences that we learned from the project. Also, this building, retrofitting and labeling. So this could be quite a good methodology to be applied, and later to have projects with other buildings to make the same thing. And also how we organize our own campus, because we have several institutes and they need to talk with each other. So integration here is a very good challenging, and we are quite learning on this process as well. So I think it's that I would like to present to you today. So I'm open for questions if you have any.